Have you ever really stopped and wondered how a simple, boring block of metal becomes the body of a brand new car? Or how a thin wire gets turned into the fork you eat with? Well, today, we're going to pull back the curtain on the hidden engineering secrets of metal forming. These are the powerful processes that literally shape the world around us.
I mean, seriously, think about it for a second. We start with a totally formless piece of metal. Could be a flat sheet, could be a solid block, and then, through what looks like some kind of industrial magic, it becomes a super complex, perfectly functional part. So how in the world does that happen? It's not magic, it's engineering, and the whole thing hinges on one single core concept.
So let me introduce you to the hero of our story, plastic deformation. It's a simple idea, but it has absolutely massive implications. See, every material has a point where it'll break, but way before that, it has what's called a yield point. That's the magic threshold where if you bend it, it doesn't spring back anymore. By pushing metal just past that point, we can permanently reshape it into almost anything we can imagine.
Now, there are a ton of ways to shape metal. I mean, countless methods. But nearly all of them fall into two major categories. You can think of them as two big metalworking families. So let's break them down.
This chart lays it all out pretty perfectly for us. On one side, you've got sheet metalworking, which, as the name suggests, deals with thin, flat pieces of metal. And on the other, you've got bulk deformation, which is all about reshaping huge, solid blocks. We're going to start with the one you're probably most familiar with, even if you don't realize it. And I'm telling you, sheet metalworking is everywhere. It's the reason your computer has a case, it's behind your kitchen appliances, and it's what makes up your car's body panels. The goal is always the same. You start with a totally flat sheet, and somehow you turn it into something three-dimensional. And the most basic operation, the absolute starting point, a simple bend. The paperclip is the perfect example. It's nothing more than a piece of wire that's been bent into a really specific, really functional shape. This one fundamental action is the building block for so many other complex operations. And here you can really see the range of complexity. On the left, that's a basic V-bend, almost like you're just folding a piece of paper. But then, look at the right. That's a process called deep drawing. Here, a flat sheet of metal gets pushed into a die to create a hollow shape, like a cup. This is how we get everything from stainless steel sinks to cooking pots. It's a much more dramatic transformation, for sure.
Of course, it's not all about bending. You also need to be able to cut the metal. Think of it like a whole toolkit of options. Shearing acts like a giant pair of scissors for making straight cuts. Punching is, well, for punching holes for screws and bolts. Notching cuts little pieces from the edge so different parts can fit together. And blanking is like using a giant cookie cutter to stamp out the exact shape you need from a bigger sheet.
Okay, now let's jump over to the other side of the family. If sheet metal is all about finesse and precision, bulk deformation is all about raw, brute power. We're not working with thin sheets anymore. Now we're starting with a massive block, or a billet, of solid metal. The key difference here is something called the surface area to volume ratio. It sounds technical, but it's really simple. Think of it like this. A sheet of paper has a really high ratio. Lots of surface, not much volume. A brick has a low ratio. Sheet metal working is all about shaping the paper, while bulk deformation is about reshaping the brick, which, as you can imagine, requires an incredible amount of force. One of the most common bulk processes out there is rolling. The best way to picture it is like a giant industrial-strength pasta maker. You take a thick slab of metal, feed it between two absolutely massive rollers, and it gets squeezed down to whatever thickness you need. This is how we get those huge coils of steel and aluminum that eventually become the starting point for sheet metal parts. Then you've got forging. This is pretty much the modern version of a blacksmith with a hammer. A big piece of metal is compressed between two dies that have the final shape carved into them. The immense pressure forces the metal to flow, and it actually aligns its internal grain structure. This creates parts that are incredibly strong and durable, which is why it's critical for things that absolutely cannot fail, like jet engine turbines and the crankshaft in your car.
Okay, so we've seen bending, cutting, rolling, and forging. You'd think these methods could shape just about anything you could dream up. But what happens when the forces you need are just too massive, too big for any machine on Earth to handle? What do you do then?
Just imagine a part that's so enormous, or a type of metal that's so tough that even a multi-story forging press isn't powerful enough. It sounds like an impossible problem, right? But engineers, they came up with a truly explosive solution. That's right. You literally use a bomb to shape metal. I know it sounds like something straight out of science fiction, but it is a very real and unbelievably powerful manufacturing technique.
It's called explosive forming, and it does exactly what it says on the tin. Instead of using a giant mechanical press, it uses the immense pressure from the shockwave of a detonated explosive to slam a metal plate into a die, shaping it in a fraction of a second. The process itself is just wild. Okay, so first, you put a metal plate over a die, which is basically the mold. Step 2, you create a vacuum in the space between them. Then, the entire setup gets submerged in a huge tank of water. For step 4, an explosive charge is detonated at a very precise distance. Finally, that shockwave travels through the water and wham, instantly forces the metal into the die's shape.
And this isn't just some crazy gimmick. This extreme technique was absolutely essential for pushing the boundaries of technology. It was actually used to form complex, high-strength parts for aerospace, most famously for the legendary SR-71 Blackbird, one of the fastest planes ever built. It's the perfect example of when your conventional tools aren't enough, you invent a new one.
So, from a simple little bend to a massive, controlled explosion, these processes are constantly at work, quietly shaping the world we live in. They're the hidden engineering that turns raw material into the finished products that we all rely on every single day.
So what are the big things to remember here? First, it all starts with plastic deformation. That's the core scientific principle that makes this all possible. From there, everything splits into those two big families: sheet metal working for the thin stuff and bulk deformation for the solid stuff. And we've seen that when the challenge is big enough, the solutions can be truly radical, like, explosive forming.
All this leaves us with a final thought. We're constantly inventing new materials that are lighter, stronger, and more resilient than ever before. The challenge will always be, how do we shape them? As our ambitions for what we can build get bigger, our tools will have to become even more ingenious. It really makes you wonder, what will the next generation of metal forming even look like?